In this video, I'll be doing a detailed solution to the question you see on the screen here from the 2024 Cambridge A-Level Maths Exams Paper 2-1. If you're looking for a different question from this paper, have a look in the playlist in the description below. Or if you're looking for a different paper entirely, search around on my channel. I'll be doing all this on a whiteboard, hopefully just like you're used to your teacher doing. But remember, we're not in a classroom, we're on YouTube, so take advantage of that, use the pause button, even change the speed at which you view it. If you do find this video useful or any of the videos on my channel, I do greatly appreciate a like, a subscribe, a share, or even a super thanks. In question 2, we're given this extremely complex looking curve and we're asked to find the gradient of this curve at a certain point, at point 2, 1. Usually I like to draw a curve if I can. I can't even begin to draw this one. But let's just say it looks like this. Because there's x's and y's, it could actually go back in on itself. So who cares what it looks like? It's some sort of curve. They've told us there's a point, and let's say it's here. They're simply asking us to find a gradient, find a tangent to it. And that, as always, because we're still in an xy axis, as always, that's just dy dx. They ask for gradient, we want dy dx. So how do we get dy dx with this? Usually we have y equals on one side. So we differentiate both sides. One side becomes dy dx. The other side becomes the answer. That's not the case here. We're going to use implicit differentiation. So let's rub this out here. What that means is I'm going to differentiate both sides. And that's ddx to both sides. That's the derivative of 9, the derivative of all of this. Let me just write it all in. Natural log y plus y squared plus 4x. Now, differentiation works a lot like multiplying. That's not a guarantee, by the way. Natural logs don't work like this. If there's a natural log outside a bracket, it doesn't act on everything inside it. But differentiation just acts on each term. So we can rewrite this as ddx of, let's see, x squared natural log y plus ddx of y squared plus ddx of 4x. This is the only one easy to do. Equals ddx of 9. The derivative of 9 is just 0. Let's get rid of that one right now. Okay, these are all quite difficult. I'm going to do the middle one here first. I'll do that one a bit slower and I'll do this one a little bit quicker. To do this, we're going to use the chain rule because we can't differentiate y by an x. They're different. We could just do y by dy dx, right? But this is y squared. So how are we going to do that? Let's just fix it over here. Dx of y squared is just the same as doing what we really want here is dy of y squared. This we can do. These are the same as long as I cancel them out. As long as I put an extra dy up here, they cancel. And there was original dx. So that's what the chain rule tells us. We can basically differentiate anything with respect to x once we put this little cheat in. Whatever we want to differentiate by, we just put one top and bottom. So that will get this extra dy dx term. And that's good because I actually want that in this question. And we can do this. This is just y squared. So that's what happens here. Let me start from the beginning actually. This guy is a product rule. There's two terms. So product rule tells us leave the first term alone, x squared, and differentiate the second term. The derivative of natural log of something is 1 over that something. But this was a y, so we did need the chain rule to fix it. So this dy dx will appear here. Dy dx. Then the product rule tells us to differentiate the first term, add this on. The derivative of the first term, 2x, and leave the second one alone, natural log of y. This one here, we'll have to use the chain rule. So we'll get the derivative of this is just 2y with respect to y. And then we'll have to multiply it by dy dx. Last one, no chain rule, no product rule, just differentiating 4x, and that becomes 4 equals 0. Remember what we're looking for throughout all this. We're looking for dy dx. I want dy dx on its own equals something. So let's just take dy dx out of everyone. Dy dx has x squared over y in here, and here's another dy dx. It has a 2y plus 2y. Let's move everyone else over the equals. The rest of them, we have a minus 4 here, and this guy here, minus 2x natural log y. Let's just divide both sides by this. Let me clear a bit of room first. So just moving this bracket over underneath this one, we'd get dy dx is equal, sorry, minus 4 minus 2x natural log of y divided by x squared over y plus 2y. And that's the gradient at any point you want. All you need to do is tell me what x and y is, and I can tell you the gradient, and I know a point. So at this point x equals 2 and y equals 1. So we can just go ahead and fill all that in. You put it in a calculator if you want, but I like to show the examiner what you're doing. Minus 4 minus 2 times 2 natural log of 1 divided by 2 squared over 1 plus 2 times 1. I hope I didn't make any mistakes there. Natural log of 1 is 0, so that's just gone. 2 squared is 4. 4 plus 2 is 6. So we're just left with minus 4, this minus 4 here, over this 6 here. Remember, that disappeared into 0. And that cancels down to minus 2 over 3. And that's the answer for question 2. If you have any follow-up questions, anything you're not sure about, ask me in the comments below. I'll do my best to get back to you. Thanks for watching. Have a great day.